Good morning, ladies and gentlemen. My name is Rajesh Nishtala. Nanda gave me pretty much summarized me pretty well, so I don't need to go into that. I just want to add, I'm one of the software engineers at Facebook who has the pleasure of working with production engineers a lot. So I definitely enjoy working with the production engineering team, and I'm just wanted to reiterate some of the stuff that Pedro said yesterday about P's and Sui's working well together. Okay, so incidents happen, right? We're all part of companies. We've all seen this before. Something somewhere breaks. Somebody doesn't do something properly, and then they get themselves stuck under a bridge, right? The question here that we're going to ask today is, one, how do we prepare for them? And two, when they do happen, how do we manage them, right? Rather than speaking in an abstract way, we're going to actually take two very different case studies about two major issues that affected Facebook, and then kind of weave through the incident management process of how these incidents were handled at Facebook, and then take some broad lessons that were taken away from these types of incidents. Okay, case number one. There was a data center hardware issue. Specifically, there was a data center level power issue that happened. So what happened? On one morning, we had a bunch of alarms fire, right? We had all our alarms starting to go off. Some data center technicians reported smoke in the data center, right? So there was definitely some stuff that was happening, and it was unclear what the state of the world was. So all that we had right now was alarms firing, site operations reporting smoke, and it's unclear what to do next. So when we face these types of issues, right, we have to figure out how to make progress, how do we determine what's going on, how to fix them, and how do we quickly get to a resolution. As Nanda mentioned, at Facebook we have a rotation of people called the incident managers on calls, right? So when issues like this surface, we activate these people to help guide us through the resolution, right? The responsibilities of the incident manager on call at Facebook are, one, make sure that the right people are involved in processing the incident, right? That means that make sure that you've identified the small number of people that can get things done and that will be able to fix the issue. And probably more importantly, get the people that are adding noise to the situation out of the room, right? Because oftentimes in one of these issues, you'll find these heroes that think they know everything about everything and jump in, and they actually add a lot of churn, and that helps nobody, right? So this is a very important job responsibility of the incident manager on call. Second is to communicate the cause, right? So communicate what's going on. Facebook is a very big distributed infrastructure, and there's a lot of teams that share a lot of different components that care about a lot of different things, right? So when incidents like this happens, you'll find teams that come out of the woodwork and say, hey, my service looks like this, could this be a reason, right? The last thing you want is for these teams to come in and tell people and pester the people that are working on the issue. Just tell them, hey, we're working on this is the likelihood of the issue, and this is the role of the incident manager on call. Next, make sure that the incident gets fixed, right? Make sure that we work towards a resolution. Now, duct tape is actually a very apt response here, apt analogy here, because the types of fixes that we put in the short term to get the site working sometimes are like duct tape. They're not pretty, they're not elegant, but they work, right? And sometimes that is the best type of responses. When a bunch of people are under stress and trying to solve these problems, there's a lot of conflicts that arise. So one of the important role of the incident managers, again, is to resolve conflicts. And when we've actually fixed it, communicate the resolution. So oftentimes, because these major issues and incidents affect a lot of different teams, people just assume, oh, my issue is related to this other thing. And they don't actually put two and two together that, hey, that thing is over, and this is actually a completely new thing. Right? So it's important to communicate the resolution to a broad audience. And finally, help the review process. Understand what happened, understand the postmortem, et cetera, et cetera. We'll get into this. Okay, so coming back to our fire. So remember where we are, fire is lit, smoke in the data center, not a good state to be. So leverage our alerting and monitoring. Do we know what's going on? Unlike this fireman here, right, who's seemingly doing whatever. Funny story about this, that fire truck is in the same city as where we have our data center. So that's not a good sign for this. So monitoring every level of the stack, right? Understand, do we know what's going on? Do we have the right people involved? Are they getting the right set of data? Do we have other events that we can correlate it? Is this real? Is this a monitoring impact? What are the downstream events that's happening? Okay, great. We've determined that the issue is real, that there is actually a power issue in the data center that we need to resolve. It's deemed that it's not crazy urgent because obviously we're still able to serve some semblance of traffic out of the data center. So at this point, the incident manager on call and the teams are really faced with two options. Option number one, do nothing, right? In a lot of cases, this is a fantastic option because systems are, for the most part, do heal themselves, right, when code is written properly. So just waiting it out and not adding fuel to the fire is a great option. Option number two in this case also is to drain the traffic out of that data center, right? So this was our Swedish data center, so like pull the traffic out of it. How do we make this decision? We have a very short amount of time in order to make this decision, and how do we actually make sure that we make a very confident and correct decision here? Well, the answer to that is disaster readiness, right? We plan for this kind of stuff. We know that this kind of stuff will eventually happen. So when it does happen, it doesn't take us by surprise. Facebook is a globally distributed service, obviously, that many people rely on to communicate with their friends and family. Especially during times of natural disasters, we find a lot of people leverage Facebook to let their friends and family know that they're okay or that they need help, right? And for us to be down in the event of a disaster is absolutely unacceptable, right? We need to be able to facilitate communication amongst friends and family. So that means that we must be prepared for all types of disasters. So we prepare for them. We fire drill it, right? Because practice makes perfect. How do we do this? Well, we actually take data centers and drain the traffic, drain all front-end services, cut the networks, actually put in ACLs to ensure that we do not see cross-regional traffic across the data center, so network partition it, and then try to find services that, or find things that break, right? If your system breaks because you've cut the network, well, that means that your system there is a single point of failure and that it needs to be addressed. Once we have that, then probably comes one of the hardest portions of this. It's very easy to turn things off, right? It's much more painful to turn them back on. So have a clear plan of the bring up, right? What is a set of ordering and what is this list of steps that we need to do in order to get the site back into a good shape? Or what is the thing back to take traffic properly? In a spaghetti mess of services, it's really important to assess out what depends on what and who depends on who. And most importantly, run that plan. Make sure that we execute on this plan. So that prevents us from having single points of failure, right? The other key caveat of understanding disaster readiness is that can the remaining data centers handle the traffic? When you take one data center away, whatever n number of data centers that you have left have to handle the site load. Because if they start failing, then you risk further cascading failures. So again, we test for this. We very routinely run load and drain tests on our infrastructure. What is a load test? Well, we concentrate live user traffic into a smaller subset of our infrastructure and measure what happens under stress. And we do this in a very controlled and automated way, right? So we have a set of monitoring saying, hey, is the site look okay? Okay, concentrate traffic. Do things look okay? Concentrate traffic. Oh, something broke. Back off, right? And by doing this very regularly and routinely, we can get a very accurate estimation of how much each data center can take and what kind of regressions there are. The reason that we do this is that, yes, we do have fancy capacity modeling, and yes, we do have all these other kind of things that you'd expect out of a company like Facebook. But empirical evidence is also a very key component in verifying these models. Okay, great. So from these two pieces of fire drilling and load testing and everything like that, we are very confident that if we were to drain the data centers and if we were to make these decisions, we'd be okay. So all of this stuff was done in the past, so in the span of 5 minutes, we can just say, hey, I'm just looking back through the data here. It looks like we're good. Let's go ahead and drain it, and let's not risk anything else. So what do? We just drain the traffic out of it. Now, in the previous slide, I talked about this infrastructure that was able to load and drain clusters, et cetera, et cetera. That infrastructure is run on a routine basis. And guess what? We can use the same code and the exact same set of infrastructure to actually do this types of heavy-handed operations, right? And we can be confident in it because we use that same software every day. And when it breaks, it's not breaking during the worst possible time like this. And we can be confident in the data, which is very important. So when incidents like this happen, you can't solve it by yourself, and there's no one person that can be that lone ranger that was going to go fix the site, right? And it's all about teamwork. It's all about coordinating the teams. So what do? Team number one, run the traffic drain. It's a piece of software that needs to run. Yes, it is automated. Yes, it does do the right thing. But you know what? On times like this, let's just put some extra pair of eyes on it and make sure it is doing the right thing, right? So just dedicate a couple of people, just run the drain. They know what they're doing with that. Team number two, monitor the rest of the site, right? So don't focus on the fire over here. Look at everything else. There's another set of people that are going to look at this stuff. Focus on make sure that the rest of the site is fine and coordinate with the team that's running the traffic drains. Team number three, figure out actually what happened in the data center. What are the services? What are the next steps that need to happen, right? And make sure that you are coordinating the response. Then start the service shutdown. Now, this is where our containerized services and automation are a huge benefit. Because with containerized services, we force service owners to tell us, one, where their services need to live, right? And two, probably more importantly, give us code that tells us how to shut down your service. Not just give us a runbook, give me a script that I will execute automatically, right? And all we need to do is just execute those scripts, and we're able to effectively move stuff around. Right? And this is how we're able to manage a relatively large piece of infrastructure with a relatively small team. Of course, there are special snowflakes, and I'm sure all of you have those special snowflakes in all your companies as well. For us, I think the database tier qualifies as a pretty special snowflake for us. So again, automation here is great, and it really helps us out. Okay, so now we've mitigated the data center, mitigated the SEV, we've drained the data center. Where do we stand? Well, EU users are starting to see a very slightly elevated latency because they don't have a European data center to go to. That's okay, right? During incidents, we can tolerate a little bit of extra problems while we figure things out. The facility teams are investigating. The fire departments have come and gone, right? So we're okay with that, trying to figure out exactly what happened. And we've also broadcasted the broad engineering team that, hey, be careful of major releases. Don't stop major releases, but be very careful and be very cognizant that the site is a little bit more of a precarious state, right? And stopping everything, stopping all development, by the way, at a company like Facebook is a very handed approach for us. We try not to do that as much as we can, because there's a very large engineering org, and stopping development in a very large engineering org means that we're wasting hours and hours of productivity, and that's not good for the company at large. So figure out what can go out, figure out what is the minimal stuff that we need to stop, but be careful, right? Okay, now the issue is resolved, right, and we can turn things back on. As I said before, hey, there's a runbook. We can plan out that runbook, and hey, guess what? Process is not always a dirty word, right? Having a runbook and having a clear set of steps that we execute will greatly help us undrain the traffic and get us back into a good state. So we undrain the traffic, and voila, our data center is back up and running. Great. Now you might be sitting and thinking, great, Facebook has a plan for everything, right? And nothing hits them by surprise, and whenever something happens, they know instantly how to react. The answer is no, that's not the case, right? There are definitely cases in which we have problems that come to surprise us, right? And the key for understanding these is to apply our previous lessons from before. So again, let's walk through an example where there was an issue that surprised us and caused cascading failures through the system. So first of all, what happened? So there's a major site-wide rise in the error rates, right? So alarms started going off. People saw major error rate spikes. Teams were running around saying something's going on, something's going on. Probably worst of all, it was not affecting just one data center. It was affecting all our data centers, right? Or components of all our data centers, right? So again, we have a major rise in error rate affecting multiple data centers simultaneously. I'm sure all of you have faced this before, right? This is a scary situation, and we need to figure out how to get things under control and get it under control quickly. So this guy, you might have seen yesterday, calls me and says, get online right away. Right, and says, we need help. We need to figure this thing out. So what if there's no runbook, right? The really important thing, again, if there's no runbook, is to stay calm and make sure that we look at all the situations and all the signals that we had in hand. So let's get a report. What's going on? What changed? Was there a code push? Was there a configuration push? Was there a configuration workload? Was there a workload change of some sort? What are the data centers that are affected? Which hardware types are affected? Right? And so all of these kind of questions will give you answers and give you direction into where to solve the problem. And issues like this, we have a special team at Facebook called Web Foundation. And they're like the Facebook SWAT team, effectively, right? So there's a set of engineers that know a lot about a lot of things. And when stuff like this happens, they are mostly all jump in right away and are able to like debug very, very nasty issues, right? You can think of them as providing very critical technical details to help the IMOCs make their decisions. And so, again, we have a hunch that we're in the middle of a cascading failure, and they identify that, and so we have to figure things out. So before I explain exactly what happened, let me give you a quick overview of how Facebook is architected. So for all of you that were in the traffic infrastructure talk, you kind of saw the story of how requests get from the internet to our web servers, right? So I don't need to belabor those points. So we have multiple front-end clusters, and they go through our edge pops, right? So, and within these individual servers, these servers also talk to our caching infrastructure, our ads infrastructure, and our newsfeed, et cetera, et cetera. So what happened? So we had a few set of web servers that completely got overloaded, and then they went offline, right? And the next set of web servers, another set of web servers took over the load, right, and had to shoulder the load, and they got overloaded, and they went offline. And finally, the rest of the cluster experienced a high set of load, and they went offline, right? When the cluster crumbled, I know it's pretty dramatic, but it was pretty dramatic that morning. So you would normally think that shifting traffic away from web servers actually fixes the problem. That's what load balancing is all about, right? So I'll actually get to why that didn't happen later in the talk, but just kind of keep that in the back of your head, that load balancing normally does fix things. When you shift traffic away from stuff, it gives the machines time to heal and time to come back. But it did not happen. But keep that in your head as we go on. Okay, so here's a graph of how fast things went south. On the x-axis is time in minutes from an arbitrary time. And the y-axis is the percentage of healthy web servers, right? So normally we're running like with most of our fleet healthy, and then within a span of 2 minutes, we lost more than 40% of the web servers in one particular cluster, right? That was the first cluster to go down. And then after the last cluster had fall was in another 4 minutes after that. So in the span of 6 minutes, we had lost a non-trivial amount of our capacity, right? So that sounds pretty scary, and yes, it was. So one of the really interesting things about timelines like this is that when we have monitor infrastructure, it's really hard to tease apart what is a cause and what is an effect, right? When there's a condensed timeline, it's really hard to say, hey, this was because of this, or this was because of that, right? Or this was a result of that. Right? And that causes a lot of churn through the organization as you try to find out these issues. Right? So we'll get to that as well. So Sysadmin 101, right? When these servers came back off, what would we have to do? Well, turn them off and turn them back on again, right? And unfortunately, that's what we did. By the way, it's actually a non-trivial exercise to turn off and on a large number of servers, right? It is not an easy task, and we got good at it. So, so reboot all the servers. It's externally stabilized. So now, for all the people looking at coming into the site, it's externally the thing has been mitigated. Like their fatal rates and error spikes have been going down, right? But we have no idea what happened. Question? Do we have to send the traffic? Yeah. In this case, there was a large spike in the, there was a non-trivial spike in the amount of errors that happened on the site. Yeah. So again, how do we deal with this sort of issue? Again, where are we right now? We've come back from a mass round of reboots, right? So what is Team 1 doing at this point? Rebooting these servers, right? Like playing whack-a-mole with them, literally. Like whatever's not coming back up, try to bring them back up. Try to get those parts of the infrastructure that were affected, get them back up. 2 is to disable the automatic remediation. There's a lot of automated remediation that'll kind of go crazy if a lot of alarm bells are firing simultaneously, right? And that type of automation can possibly add fuel to the fire. So disable all the automation and then selectively re-enable the automation that we think will help, right? So first of all, disable it and then make everything be opt-in. Team number 3, how's the rest of the site doing, right? Is everything stable? Team 4, hunt for any changes to the code or configuration, right? Something has changed on the site. We need to do this. And oh, by the way, while all this is going on, Facebook is a very visible company, right, in the press. So big major news outlets are asking us what's going on. And Team 5, answer the press inquiries, right? So again, one of the roles of the incident manager on call is to coordinate these efforts as well as provide technical guidance to the PR team to help them respond to these types of issues in a way that they see fit. Okay, so we're kind of out of the situation, like the user visible impact is mitigated, but we still don't know exactly what the root cause was. And until we find the root cause, we have to assume that we're vulnerable again, right? So the war room, what the fuck just happened? What was that, right? That was literally the question in everybody's mind at this point, right? And until we find it again, we assume we were vulnerable. I can't stress this enough. This is, again, where the condensed timeline made things really hard, right? When you're doing this type of investigation, if things around you crumble within 6 minutes, and you have a service or something like that that issues sample points every 4 minutes, right? Do the math, right? It's really hard to tell if this was cause and effect. So what is a war room doing? I can't stress this again, teamwork, right? Parallelize the effort as much as you can. Team 1. Focus on the health of the site. Don't worry about what's going on with like the investigation. Kind of chip in if you can. Team 1, how's the site doing? Team 2, try to get a repro of this at a smaller scale. We need to understand what's going on, and we need to understand when we figure out it, if we've figured it out, that we've actually been able to fix it. So get a repro. What configs happened? Sorry, I missed a typo here. What are the configs that changed? And what was the code that was pushed? Team number 6, analyze the error logs and telemetry to get any kind of signal that we can out of this. And team number 6, by the way, archive this away for later forensic analysis. A lot of tools like that we have available in Linux, for example, they report data and they store away data for 1 day, and they do it on a very fine-grained basis, right? So that's all great. But after a few days, that data goes away, right? And we no longer have fine-grained telemetry on what happened. So a very important point of doing later forensic on this is to save the data, right? Because the answer's in the data somewhere. So what did we learn? Well, this was the memory usage with time on the x-axis and percentage of memory used on the web server on the y-axis. And you can see right when we start copying the new release binary, something ticked up, right? And we started consuming a lot more memory than expected. So again, we need to reproduce this on a smaller scale. The theory right now is memory exhaustion, right? That the web servers ran out of memory and that somehow caused a cascading failure. So what do? Using the same infrastructure that I talked about before about load testing, we're actually able to reproduce and concentrate traffic in order to get a small subset of the infrastructure under high load, right? And then repush the site. The reason that I have a container ship picture here, the bridge of a container ship, is that managing Facebook's infrastructure is not like navigating a small, nimble speedboat through the San Francisco Bay, right? It's like driving a container ship through a very small port. Any kind of changes or any kind of things that you do are likely to be, if you aren't careful, you're likely to run over somebody, or worse, and it's a very bad time for everybody, right? So we have to be very careful in how we do things and be very careful and coordinated. So what were the results of the experimentation, right? We were able to reproduce a failure condition on one small case. We triggered memory exhaustion, which is great. Like, we were all cheering when we saw this small set of clusters start behaving the same way, right? This was phenomenal because we knew at that point that we had reproduced it and that we could reliably reproduce it so that we could test a fix. So what was the key here? We knew there was memory exhaustion, and we had to reduce the memory footprint of the web servers, and we had to do it fast. Now, what followed was actually one of my favorite parts of working at Facebook over the last 5 years, right? We realized that we needed to reduce memory consumption in the web tier, and we needed to do it fast, so we organized an infra-wide hackathon, right, in which the goal was to reduce the memory pressure on the web tier. And a lot of different teams from a lot of different organizations came together and helped focus on this one issue. And in a matter of a few days, right, we were able to do amazing things, as this graph shows. So the x-axis here is hours of uptime, and the y-axis is percentage of memory used. This is the release the week before the outage, right? So you can see it climbing. It normally climbs because of caching behavior in our web servers, and mostly that. This is what happened, the release for the week of the outage. And you can clearly see that there was a regression, right? The rate of change was much higher than expected. So this release was unfortunate. So it's not like this was super building up over time. The green line is what we were able to do 1 week after, right? And this was a bunch of infra teams coming together to solve these problems. And you can notice that there's almost a 15 to 20% drop, right, in the amount of memory consumed by the web tier, right? So we were still a very fast and nimble company and able to execute on this in this matter of days, and this was amazing to see. And this is the next 2 weeks after, so slightly more long-term fixes were landed. And you can see that we were still making progress here. So this was amazing. So, and more importantly, we added a lot of tooling to make sure that this never happens again. Why do some requests take up to 3 gigabytes? Right? That's interesting. Why is the memory limit unset on some requests? Why are people turning their safeties off? Right? Let's ask them. Figure out where the timeouts and memory memouts are happening. And we did have some sort of memory tracing so people could kind of figure things out, but we realized they were very complicated, and you needed a PhD in systems performance in order to really understand what was going on, right? So better to have better and simpler memory traces that are accessible by a wide swath of engineers, right? And that helps everybody. But we're still not happy, right? Memory exhaustion by itself is a very unsatisfying answer, right? Because there's a lot of things inside the Linux server, inside our HHVM server, that protect against this, right? Linux has an OOM killer that should have done the right things here. Why didn't they work? Right? All of that stuff should work. When a system runs out of memory, the fork system call usually fails and returns -1. We had a daemon bug that interpreted -1 as a valid PID. I can see where this is going next. Kill -9 -1 kills everything besides yourself and init. Whoops. And rebooting was the only way out of this. I think the slides speak for themselves. I don't need to say anything more about this. I think one more little piece of information here is that this was actually caught a couple of weeks earlier. Somebody noticed this in the code and was like, hey, this isn't right. Let me fix it. And they landed a diff. It was fixed, but it never got pushed. So if you have fixes like this, push them out, right? Push them out. Get them out there. And one of the reasons that it wasn't pushed is that, when it comes to widely deployed things, we try to move a little bit slower because we don't want to affect infrastructure. So again, having a very fast cadence with regular releases means that you can do these types of hot fixes with high confidence, right? That's the kind of stuff that a very fast release cycle gives you. So this is really important for stuff like this. Finally, review the incident, right? So we spent a few weeks on this one. We spent a few weeks looking at exactly what happened, looking at the timelines, figuring out what were the actual root causes. And that issue about the kill -9, -1 thing was discovered during a few weeks after the incident actually happened, right? So now it actually feels satisfying. We know what happened. We know the timeline of what happened. We know that copying the new release binary was not an actual root cause of it. Like, there's nothing wrong in that process. It was a trigger for a much deeper problem. Right? Understand how this issue affected the site, forensics to build a better timeline. The talk from Sue yesterday at kind of outlined this really well about the incident management process. And again, we leverage a very similar process in-house at Facebook. And you leverage the preventative tasks, short-term, long-term, and organizational to get this stuff fixed. So how did we get here? Well, teams are heads down on efficiency improvements for a long time, so memory kind of just slipped aside a little bit, right? So that's how we let the memory climb. But to be clear, that release that week had a regression. So our Containerized system did let something slip through. And since the issue, we've actually beefed up our Containerized system significantly, right? So I'm much more proud of it now than I was before. So Facebook has seen its fair share of this kind of stuff, right? They happen all the time. Shared components. How do we make sure that we are able to solve these things once? Implement the stuff once, right? Things like throttling, load balancing, connection pooling, automatic retries, monitoring and alerting, health checks, right? These are all things that are designed to prevent these types of issues from happening. But don't make everybody invent these things all the time over and over. Put them in one place. Let people share code. Sharing is caring. The next is containerized deployment, right? So in the first issue, in the first case that we had, we noticed that we were able to drain a region relatively quickly because we had everything in a container. This was able to isolate processes from each other, right? So canarying does that. It allows you to canary new releases, canary new configs, right? Containerization helps you automate a lot of this stuff, which is critical to our infrastructure. Do stage software rollout, right? Enforce CPU, RAM, and disk limits, right? And we use Linux containers inside. For both of these types of things, software engineers love to give you configuration knobs, right? If you look at the spec for a lot of these systems, you'll see like a 20 or 30 page thick book of all the configuration options that you have available to you. It is very difficult to know if you got the right combination of all the things because the space is actually exponential, right? Users shouldn't have to worry about a lot of these details. Choose the same defaults. Choose what makes sense for the most number of people. Second, having good monitoring and alerting has saved us many times. There's a lot of issues that we have caught early, right? That we have caught them before they've hit the site because of effective monitoring, canarying, and alerting on this, saying, hey, we're about to push something that's going to cause a major problem. Start sounding the alarm bells. And this is a very important piece of infrastructure that we have. Load shedding, as the question alluded to earlier. Sometimes something is better than nothing, right? If as a service you try to serve everything, you're going to serve nothing, right? Because when in an overloaded state. I'm sure you've all stood in line at places where the queues just kept growing and growing and the service was not moving along, right? This happens all the time in systems too. So again, load shedding is good. And configuration management, of course, right? Configuration changes are like hotfixes. When you make even the smallest of configuration change can have dramatic ramifications through the system, so treat them very carefully, canary them out. Don't reinvent the wheel. People love to write their own new configuration scheme, right? Or configuration distribution mechanisms. There's a lot of relatively good technology out there on this stuff that is able to do good things, so leverage it. And have to be able to run with 2 versions of the config. Oftentimes we see people that say, hey, I have a config that was rolling out, but my 2 versions of the config were incompatible with each other. Fix it. Make sure that it can work. And one of the most useful things that we've had is the ability to have history on our configurations and ability to revert a configuration saying, hey, this is a known good state of the world. Go here. Right? That's a very useful thing to have. And test your configs. And finally, as Pedro alluded to earlier yesterday, let the machines play the whack-a-mole. Playing whack-a-mole from engineers' front is not fun, right? Let machines do it. They're very good at playing whack-a-mole. And at scale, single servers becoming unavailable is common. Automate this. Right? It's worth it. And allows the production engineers to focus on harder problems like tooling, et cetera, et cetera. Okay, just to finally conclude about a couple of high-level points about incident management at Facebook, right? What do incident managers at Facebook do? Again, one, corral the right people in the room, right? Set up the teams. Communicate the causes. Fix it. Get it done. Fix it. Communicate the resolution. Tell everybody when the issue is resolved. And finally, review the SEVs. One thing I really enjoy about incident management at Facebook is that the incident managers are empowering the engineers, right? They empower teams to fix the systems themselves. It is not like a network control center or a NOC or anything like that. It is a person that helps the teams, empowers the engineers in order to help them fix the issues that they're having with their systems because they know best, right? And they know how to fix themselves. Get them the right people and get them the tools that they need to help them fix the problem. Focus on the resolution and prevention and not blame. Don't blame anybody because after all, we're all on the same team. So with that, take any questions. Thank you. Questions?
One question that you kind of touched on is about like configs or like hot fixes. So how much does your configuration management system look like code deploy in that regards?
So our configuration management system, actually, we have a system dedicated to configuration management. It's called Configurator, right? It effectively, there's a thrift-based language that allows you to specify configurations, and then you write configurations, you code review configuration changes, and then when you commit these changes, like you do normal code, it then gets pushed out. And there's an opt-out of Canary process. So when you push configuration changes, they're automatically opted in, so they get Canary to a small subset of the machines before they get rolled out. So we have a special team that manages just this thing, and it is specifically for this purpose of review and testing and everything like that. And there's also mechanisms in that configuration management system to write unit tests for your configuration, right? You can specify like, hey, X and Y values have to be within these tolerances, or these two things are semantically impossible to have together, right? And assert on that, reject configs that have that kind of thing. Good question.
Alrighty, I've actually got two questions. So earlier, you said when conditions like this occur, we call on the IMOCs.
Yeah.
So can we talk a little bit just about what specific threshold needs to be crossed in order for the IMOC team to be engaged? And the second question, there's obviously two different scales of incidents. I'm wondering, is the IMOC scale incident management process materially different or similar on most levels to the small scale single team response?
So the IMOCs tend to be involved in one of two cases. One is the somewhat larger issues on the site, not necessarily like the larger scale, holy moly, the world's on fire kind of thing, but even a couple of steps below that, right, to make sure that the resolution is flowing on smoothly. And even for small issues, it is actually the role of an incident manager there to make sure that small issues that are affecting a very small piece of the infrastructure are not just sitting there festering, and that the issues are being resolved. So it's a combination of kind of both things, right? So, like, actually this week I'm currently on call, so I'm hoping nothing happened. Yeah, so Pedro's actually covering me, so he's back there. I would be looking at all the stuff that's open, making sure that all the small issues are actually making progress, or there's a reason that they're blocked, right? So we're looking at everything that's ongoing on the site. Try to keep everything in our head. Question.
So you mentioned the hackathon you organized to reduce the memory footprint.
Yeah.
So what I found is that if we organize that in our company, people will be like, why should I be interested in this?
Yeah.
Like, So what kind of incentive or how you make sure they participate?
So this was actually one of the incentives here was, hey, this had to be a huge effort, right? Because we faced a major issue, and the major issue was pretty visible, right? So a lot of people knew that it happened, and it affected a lot of people, and so that one actually was itself to motivate a lot of people. And for that extra set of people that kind of needed to come in, this is where our management team like Jay Parikh and Pedro were really instrumental in getting those teams on board, right? So I think this is where having an effective line of communication with like senior levels of management saying, hey, this is what we need out of the company right now, and getting them to prioritize this actually helped us a lot. But in this case, I didn't really need to tell Pedro or Jay that we needed to do this. They knew it themselves.
I'm an IMOC that's on call right now as well. So the question that I had though was, how do you identify other IMOCs within your organization or within your company?
How do we identify other ones?
Yeah, like people who aren't them yet, but could be in the future.
So it's an interesting story. So last year around this time is I went to Pedro and I asked him, hey, can I be an IMOC? Because it seems like a fun rotation because I like to learn a lot about a lot of different things, right? And I think what I've tried to look for in people that I think would be good, and I suggest like, hey, maybe you should go talk to Pedro, is that people that try to work outside their team boundaries on a routine basis, right? There's a lot of set of issues that happen within your team, and there's a set of people that are coming within your team and like fixing one thing, but kind of have blinders on when it comes to the rest of the site, right? But there's also those people that, will take a much broader view of the site and like look at the things and want to learn a lot about a lot of different things. They might not know everything about everything, but they want to learn a lot about everything, right? And those types of people, I think, are probably good people to have in. Yeah.
Yeah, my question's actually fairly related to that. I was going to ask what qualifications you look for in an IMOC, but you kind of answered that. So I'm just wondering, what does your IMOC rotation look like? Like, how big is it? Is it like a 24/7 sort of deal? And also, so when we have a similar sort of role, and for us, it tends to be like a lot of the people who are really good at solving those problems have a hard time communicating during the incident because they want to just be off fixing the problem. So how do you balance the issue of communication versus resolution? Because obviously in an incident, first priority is to restore service.
So so there are two questions there. One, the on-call rotation is about 8 to 10 people. I forgot the exact number right now, right? So there's 8 to 10 people on the rotation. The explicit goal of the IMOC that Pedro hammered into me over and over because I'm a software engineer and not a manager is don't try to fix the problem, right? It's the responsibility of the incident manager not to fix it. Like it's an explicit non-goal. There's a team called like the Web Foundation team, like the SWAT team that we have, whose goal is to fix the problem. Right, and so the goal of the SWAT team there is to actually come up with a set of data, come up with a list of action items, and like suggest a technical course of action. And it's up to the IMOC to ensure that the right people are in the room and like help corral that decision.
Sorry, just a quick sort of follow-up question.
Yeah.
So we're a bit of a smaller company. So often, like the incident manager on call will be like the first responder.
Yeah.
So how do you like decide like in that sort of situation like whether you should like try to mitigate or try to communicate?
So in our case, actually, the incident manager on call is rarely the first responder, right? The Web Foundation team actually has all the alarms, and a lot of the engineering teams have a lot of alarms and alerts, and they're the ones that surface issues already. So by the time the incident managers get involved, there's already an issue that's ongoing, and there's already a point of contact where we can go and say, hey, give me a status update. What's going on? Who do you need? Right, and that's how we enter a conversation, right? We don't enter it saying, hey guys, there looks like something's going on. Why don't you come in, right? It's more the second front. So the technical people are the ones that hopefully are the ones filing the incident. Yeah, and like we have a tool that called Sub Manager that Pedro mentioned that kind of coordinates this entire process.
Given you have teams across the world, how do you manage, or what type of tools do you find useful at 3 o'clock in the morning on a Sunday? When everybody's at home or sleeping or not working?
Right. So we had the luxury of having an office in Dublin, right, that we actually split the IMOC rotation between morning and evening. So the person in our EU offices are able to take the rotation during nighttime, and there's a fair amount of people that can take it during that time. We find tools like our Sev Manager and tools very effective because simple things like when you post a link for a graph, automatically taking a screenshot of that graph and posting it in the side, like the really simple things like that are able to give people a lot of context of what's going on, right? And having a lot of information at your disposal quickly of like summarizing an issue, summarizing the key players involved and finding out what's going on has really allowed us to really scale that out. And I think the better tools to communicate, better tools to, that help build out to facilitate communication are worth a lot, right?
How much communication do you have to do with, say the PR folks, to notify, outside users, that sort of thing, so they can get ahead of it?
Right. So the PR folks are actually for us are very good, right? They are technically very strong, and you can give them a very technical summary of what's going on, and they're able to kind of tease out what they want to say and how they want to craft the message, right? So when it comes to talking to PR, the PR folks typically only directly talk to the IMOC. The PR folks are not reaching out to a bunch of engineers, and it's the IMOC's role here to make sure that the PR folks are looped into that the IMOC is communicating to the broader audience, right? So the people fixing the issue shouldn't be the ones, they should be focused on fixing the issue. They shouldn't be focused on anything else, right? It's up to the IMOC to make sure that all the other kind of act as a shit umbrella, if you will, and make sure all the other stuff is being taken care of.
You mentioned the incident manager on call that helps drive and run the incidents as well as communication.
Yeah.
Then you also mentioned the SWAT team that
Yeah.
is focused on technical resolution of the problem. Is there any correlation organizationally within your group where these teams sort of work together or have a work hand in hand and organizationally?
So organizationally, there's no they're like parts of a different org, but I think the relationship is a lot more personal, right? Like the people that are on that team, I know them very well, right? Like there's a lot of trust on both sides, right? Like so during the SEV, for example, when it was the Web Foundation team that we helped in, like I personally have a very long personal relationship with those guys. So when they ask me for things or when I'm asking them for things, like they know where we're coming from, they know what's going on. So I think that building that personal connection with that SWAT team between like these incident manager on call and the set of Web Foundation people has helped a lot, right? So I think that's.
Question about, in terms of your Web Foundation team, it sort of seems like they're the front door SWAT team in some respects. Do you guys have sort of analogous functions with the organization? Because it sounds like they lay across many teams versus what's operationally within a team. So say for your caching tiers, your persistence tiers, is there an equivalent group that gets engaged in these type of situations that looks at it in an aggregate fashion?
Yeah, so there is actually, for major pieces of the infrastructure, there are other teams that are kind of focused on fixing them. Like, for example, there is a team for messaging. Right, so like a messaging foundation team. So if there's a major issue around messaging, these guys know a lot about how the messaging stack works, and they know how to do that really well, right? And the ad stack in a similar kind of way, right? And we actually do have domain-specific IMOC. So if there's a messaging SEV, there is actually going to be a messaging IMOC that might know a little bit more about how this works. The main IMOC will still communicate with that one, but we try to find and identify teams within that sub-organizations that can play that role of SWAT team debugging in their piece of the infrastructure, right? Okay.
And then I have one additional question. So when you're running an incident, or a SEV, I guess you call it, how do you effectively control communication between all the teams? Do you have like IRC rooms that are segregated, or because you have to kick people out sometimes, right? But how do you keep it structured?
So we try to communicate over IRC, right, mostly, and we try to dedicate one channel, right, to say like this is the channel of communication, this is where all the communication stuff is happening. And it's IMOC's responsibility again to read this channel, make sure they're keep getting updated. And if stuff is not if there's a lot of like cross conversation happening, tell those people to, hey, go find another IRC channel, right? And if the issue is severe enough, it's the IMOC's responsibility again to go find a war room and get the right people into a war room and say, hey, let's meet in person. This textual-based communication does not have enough bandwidth for us, right? So again, this is again part of the IMOC's role. So this again goes into the broader picture that it's not the engineer's responsibility. The engineer's responsibility here is to fix the issue, not have to deal with all this other stuff that arises during major issues.
Sure, thanks.
Yeah.
Sorry, another question.
Yeah.
So one of the problems that we have during an incident is we have a lot of people who want to be really helpful.
Yes.
And
Yes.
like they're not always, right?
Yes.
But
Yes,
so
yes,
how do you decide like who's actually probably going to be helpful, and how do you tell the people who probably aren't that they should, you know, go away?
Yeah.
And like how do you, so yeah, like the soft skill part of that.
Right. So the identifying the people that we know are going to be helpful. So one, there's a set of SWAT team, right, that typically knows what's happening, right? So they're usually very helpful. And two, if you find somebody, what I normally do is I look for look at the on-call rotation of a team where the thing's on fire, and if people are jumping in that are already like related to that on-call rotation or working in similar areas, I normally let them speak because they know a lot about what's going on. But if you find some random person saying, hey, why don't you just, you know, clear all the caches right now because that'll help, and like this, that, or the other because that worked in my last company, we just basically tell them to fuck off. Right? Like literally, when the site's on fire, that's the last time that you need something like that. That's not the time that you need to like worry about somebody's feelings because.
So like, are you actually like kicking them from the channel, or are you like?
No, we don't kick them from the channel, but we tell them to like, you know, politely just.
You get them to elect to leave. Basically.
Yes.
Okay.
Yeah, like, or tell them like, please, you know. Yeah. Yes. Question.
I kind of work for a SWAT team that helps out IMs in tooling and identifying issues. So one of the things when you're IMs, and you had a great talk about what you do during the call. My question is related to post-call and before the call. One is, how would you prioritize tooling features in your SWAT teams or your what is needed during the incident? How is your IMOC team instrumented in pushing those features at a higher priority? Do you guys do it, or do you rely on a SWAT team? Or how does it work?
So the tooling and stuff, so the way that the SWAT team kind of works, the White Foundation team, is that they have an on-call rotation as well, right? So there's a set of like people that they go through an on-call rotation. And when they're on call, they're kind of watching the health of the site, making sure that everything's okay. When they're off call, they're building the tools, right? So a lot of the tools that we use to kind of run and drive the site are routinely being made better by the people that rely on them the most, right? And so by having them build and work with their own tooling, they're actually making the tooling better, making their job more efficient and helping themselves out.
Right. My question is a little more subtle. I want to know, would you have a communication between your web and your own IMOC team on which features have been more important in figuring out the symptoms, or how much empirical data does it forms, and how do you do it?
Right. So after every SEV, we have a review process, an incident review process that kind of goes through, one, how many people are affected, right? Two, how is the issue detected, and how long did it take to detect the issue? Right? So if the issue was detected in a couple of minutes with alarms that fired at the right time that give us the exact right signal, then guess what? The tooling worked. But if the issue took like 1 week to find, then something somewhere got slipped and we need to work on the tooling, right? And so depending on the breadth and scope of the severity, like we cut out these incidents and then we cut out these tasks and then prioritize them as depending on how the incident happens. And prioritizing it, as Sue mentioned in her talk at Google, it's a very similar story. It's very hard to kind of fold this in with the rest of your day job, but it is something that we want to do. Okay, a final question.
No, it's a pretty quick and easy question. So in a lot of environments where you have service teams, it's pretty easy to identify when an issue happens, who's responsible for triaging it. But in your environment, who's responsible for, because it's the sum of all parts. So for example, Facebook, the web property or mobile is down. Who's the individuals that are charged with the pipeline metric, and then how do they?
Yeah, so for us, it's the Web Foundation team that kind of is watching the top high-level metrics, right? So it's the SWAT team, effectively. And when something goes south, they've built a lot of tooling and everything like that that's able to sound the alarms. For different parts of the organization, though, like we have had enough tooling and automation where we can actually identify subcomponents that are breaking. It's the Web Foundational team saying, hey, there's a spike in the error rate. And the feed team might also notice, hey, feed is also unhappy here. Right? So those two events all are automatically coordinated, and there's no real handoff or transition that needs to happen. It's just all the right people are already involved.